Okay, great. So let us start with the canonical forms. So let us start with the canonical form, right? So this is a synonym to make the partial differential equation to bring into a simpler form. So that's what it means. So canonical forms meaning making it to a simpler form. Now actually how we are going to make it into the simpler form, there is a standard methodology for that. The standard methodology is, suppose if I have it, so let us take one simple example, then based on that actually we will proceed. Just a minute. I'll take one example. Okay. Note down this problem. Dou square z by dou x square minus dou square z by dou y square equal to 0. Dou square z by dou x square minus dou square z by dou y square equal to 0. So this needs to be reduced to the canonical form. Right? So to bring into the canonical format, right? So the way we proceed is, first actually you have to identify the equation in the form of, that is r into small r plus s into small s plus t into small t plus f of x comma y comma z comma p comma q equal to 0. So this is actually a second order partial differential equation where r is equal to dou square z by dou x square and t equal to dou square z by dou y square and s is equal to dou square z by dou x dou y. So this is the standard form of the partial differential equation. Or actually if I put it in this particular format, so r into dou square z by dou x square plus s into dou square z by dou x dou y plus t into dou square z by dou y square plus some random function of x comma y comma z comma p comma q equal to 0. Even here also may be a function of x comma y comma z. This s also may be a function of x comma y comma z, and r also may be a function of x comma y comma z. Now keeping that in mind, so this is what we call as, this is the equation that needs to be reduced to the canonical format. Now if you want to reduce this to the canonical format, you need to write this particular equation. So this one, s square minus rt value, you need to, sorry, s square minus 4rt. So this is as if like b square minus 4ac. So in this equation, it's a quadratic equation, right? So this is actually square here, and this is, and this one again, this is a square here. So if you put it in this particular format, this is called the quadratic equation format. So this is the discriminant part. So this discriminant either may be greater than 0, less than 0, or equal to 0. Now if it is greater than 0, then so we say that this is the hyperbolic form. So the given equation we call that as the hyperbolic format, and then the second one, if it is less than 0, this is elliptical form. If it is equal to 0, this is what we call as parabolic form. Right? So now actually for these three different cases, the methodology is exactly the same thing. So a little bit of minor changes while selecting the characteristics, actually we have to make it. Now here, this equation, if s square minus 4rt is equal to 0 or less than 0 or greater than 0. Now for this equation, if you notice, this value is 1 and this value is 1, right? Now actually, given this equation, so s square minus 4rt, so s value is 0 and then r is 1 and t is 1. So minus 4 times of r is 1 and t is minus 1. So this value is plus 4, which is greater than 0. So if it is greater than 0, this format is hyperbolic format. Right? So this is actually the given equation is the hyperbolic form of the differential equation. For that, actually, if you want to reduce any equation, whether it is hyperbolic or the parabolic or the elliptical form of the equation, the first step what you need to write is the lambda quadratic you need to write. So lambda quadratic, we mean here this equation, that is r times of lambda square plus s times of lambda plus t is equal to 0. So this is what we call as the lambda quadratic. Now in this equation, s is 0 and r is 1. Then this is lambda square and t is minus 1. So plus 0 minus 1 equal to 0, or lambda square minus 1 is equal to 0. It implies lambda equal to plus or minus 1. So whatever may be the form of the equation, whether it is a parabolic equation or the hyperbolic equation or an elliptical equation, so you need to write the lambda quadratic first. And then you have to solve the lambda quadratic and then find out the roots of the lambda quadratic. Once you find the lambda quadratic, let us say you found the roots are lambda 1 and lambda 2 are the roots of the lambda quadratic. Then what you need to write is dou z by dou x plus lambda 1 equal to 0. So this is actually one equation which you need to write it first. And similarly, dou z by dou y plus lambda 2 equal to 0. This equation also you need to write it. Then you have to solve these two differential equations first. Note down till this point, I am going to extend it. Sorry. So this one actually is dy by dx. And this is also dy by dx. Both are dy by dx with lambda 1 and lambda 2, which you need to solve it first. Done? Note it down. Okay. So once you write the lambda quadratic, then solve the lambda quadratic first. So once you solve the lambda quadratic, then find out the roots. Those roots actually you have to put it in this equation format, that is dy by dx plus lambda 1 equal to 0. Then in this particular case, lambda equal to 1, that is dy by dx plus 1 equal to 0 and dy by dx minus 1 equal to 0. So this, if you integrate it, dy plus dx equal to 0 and dy minus dx equal to 0. Now integrate on either sides, then this is going to be y plus x is equal to u or some constant c and c1, and here y minus x is equal to some constant c2. Then actually what you call this particular function, which we call as the characteristic. So these two both together we call as the characteristics of the differential equation. And these characteristics, now the first constant u equal to x plus y, you have to assume this as u, and this one you can assume as v, y minus x. So y plus x and y minus x, these are the two different differential, so two different new variables we brought in. Now actually the canonical form we mean expressing the original differential equation to a solvable or an easier way of expression. Now that solvability and an easier method can come if we can express the variables original x and y into the form of u and v rather than x and y. So that is the methodology behind it. Got it or not? Understood? So this is the standard procedure for any kind of equation. So first we have to identify the original equation, and from there actually we have to identify the s, r, t values, and then verify whether it is s square minus 4rt is greater than 0 or the less than 0 or equal to 0. And then based on that actually you solve this. But in all the three cases actually you have to write this lambda quadratic and find out the lambda values. If it is lambda quadratic solutions are only real and unequal, then we call that as hyperbolic equation, where we have got two different characteristics. Suppose if it is real and equal, then we will get only one solution. So you will be getting only u, and you have to randomly pick up the v value based on your experience, which is independent of u, and then exactly follow the same procedure. Suppose if it is elliptical equation, you are going to get the roots as a complex conjugate. Then you have to select the real part and the imaginary part separately, and u you can treat as the real part and v you can treat as the imaginary part, and again follow the expression to bring into the uv format. Got it or not? Now how we are bringing into the uv format is, so this is the new function we brought in. Now the original function z is a function of x comma y, right? So z is a function of x comma y. Now what you need to do is you have to find out dou z by dou x, and then from there actually dou square z by dou x square you can find out, so that you can put it in this place in terms of u and v. For that what you can do is, so what you need to do is dou z by dou x, you can do it dou z by dou u into dou u by dou x. Got it? Dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. So this is how actually you can find out dou z by dou x value. Got it or not? So now actually z is a function of u comma v, maybe a function of u comma v. So g of u comma v, where u is a function of x comma y and v is again a function of x comma y. Now actually you are trying to find out dou z by dou u, but u is a function of x comma y. Hence dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. This is how you have to bring in. Understood or not? Do you have any questions on this? This is a normal standard method of making a partial derivative. So dou z by dou x, which is a function of x comma y, you are bringing into the form of dou z by dou u format. So for that actually this is the standard procedure. So this is normal partial differentiation, nothing more than that. Now from there, so u is equal to x plus y, then dou u by dou x is equal to 1, and then dou v by dou x is again minus 1, and dou u by dou y is equal to 1, and dou v by dou y equal to 1. Right? Now substitute these values here. Dou u by dou x is 1, then this can be written as dou z by dou u into dou z by dou v plus dou v by dou x. Dou v by dou x is minus 1, and then dou z by dou v. Or in other words, dou by dou u minus dou by dou v of z. And that is equal to dou z by dou x. So this is equal to dou z by dou x, which implies that dou by dou x you can replace as dou by dou u minus dou by dou v. This is the simple understanding. Understood? Understood, or do you have any questions on this? Any questions? Okay. Right? Similarly, you have to do this. That is, so dou square z by dou x square, you can do it. So from there actually dou by dou x is equal to dou by dou u minus dou by dou v. So just note down till this point. I am going to erase it and then continue. What is lambda? So lambda actually, so lambda 1 and lambda 2 values I have replaced here 1 and minus 1, right? Deepak, understood? I think you are not there in the class from the start. Maybe that's why you got the confusion. So this is what we call as the lambda quadratic. Given a partial differential equation, first you write it in the standard equation format. That is dou square z by dou x square into some function of x comma y comma z plus dou square z by dou s dou y into some function of x comma y comma z, which we call as s, and then dou square z by, so this is r into r plus s into s plus t into t plus some function of x comma y comma z. So this is the standard differential equation which needs to be converted into the canonical format. For that, what you need to do is, first actually you can write it as the lambda quadratic format as s lambda r lambda square plus s lambda plus 1 plus t equal to 0. So you have to write this lambda quadratic equation for this differential equation. This is what we call as the lambda quadratic equation. It is as if like the so this is auxiliary equation for solving a normal differential equation, right? So this is as if like the normal differential equation auxiliary function. So this equation we call in this case as the lambda quadratic function. The roots of this particular differential equation, let us say this is lambda 1 and lambda 2. So because this is a quadratic equation, we are trying to solve the second order differential equation. So you are going to get two different roots, lambda 1 and lambda 2. Then you have to write for those values of lambda 1 and lambda 2 as dy by dx plus lambda 1 is equal to 0 and dy by dx plus lambda 2 equal to 0. Solve these two differential equations and then call them as u and v. And then, so by experience actually it was proved that, so this particular differential equation, which was the original differential equation, if you express into the variables of u and v, which were derived with this particular format, then this equation is easily solvable. And that solvable equation format we call as the canonical format. Got it? Now actually we are bringing that into the canonical format by expressing in terms of a variable called u, which is equal to y plus x, and a variable called v, which is equal to y minus x. So this differential equation needs to be converted in terms of u and v. Understood, Deepak? No, linear differential equation is different, right? No, it's not that way. So maybe actually that is much more simpler case than this. So this is a little complicated level because two different variables are bringing into picture. So maybe actually what we are saying is Legendre form of differential equation in linear case. What we are doing is, so if the linear differential equation is of the form x cube into d cube y by dx cube plus x square into d square y by dx square, like that x into dy by dx, if that is the format, what you are doing is you are taking x is equal to log t. And then you are trying to express everything in terms of t, the differential equation. That is one-dimensional case where y is related to x in the ordinary differential equation. Now, maybe actually exactly in the similar manner, what we are doing it here it is, we have two different variables. So these two variables actually, there actually by experience we found that x, if you can replace in terms of log t, then we were able to make the differential equation into a solvable format. Now exactly in the similar manner even here also, if you have to identify that log t, right? There actually we are straight away taking as log t. Here we are identifying that log t first. That is u and v. So two complications. One is you have to identify the variable, but here we need to identify two different variables. There it is only one variable. So those two variables, this is the standard methodology of identifying those variables. Then you can use these two variables to express this differential equation into the format of the uv. There actually we are expressing as the Legendre polynomial as a normal differential equation or the normal linear differential equation, but expressed in terms of dou by dou t. Got it? Understood or not? It is just like exactly the similar manner of the ordinary differential equation, bringing into the non-linear differential equation into the linear equation format. But there actually we guess x is equal to log t. But here we are identifying those values. So for each differential equation, it will be a different way. Is it clear, Deepak? So once you got this, then so we got this value as dou by dou x. Dou by dou x is equal to dou by dou u minus dou by dou v. And similarly, dou by dou y also, if you put it in this particular format, then dou z by dou y is equal to dou z by dou v, dou z by dou v, dou u into dou u by dou y plus dou z by dou v into dou v by dou y. But u is equal to y plus x and v is equal to y minus x. Then dou u by dou y is equal to 1. Dou v by dou y is again 1. Now if you put it here, this is dou z by dou u. So dou z by dou u into dou u by dou y is 1 plus dou z by dou v into dou v by dou y is again 1. So this is dou z by dou y. It implies from this equation you can make out dou by dou y, you can replace as if like dou by dou u plus dou by dou v. So because this is z and this is z operated on this. So dou by dou y operator can be replaced with that one. And another operator is dou by dou x can be replaced with dou by dou u minus dou by dou v. So this is as simple as this. Now using these relations, you have to express the original differential equation in this particular format. So that is, original differential equation is dou square z by dou x square is there. Now dou by dou x is this one. Then dou square z by dou x square is equal to dou by dou x of dou z by dou x. But dou z by dou x is, so dou by dou x of, dou by dou x actually I can replace as dou by dou u minus dou by dou v and operated on dou z by dou u minus dou z by dou v. So if you further simplify this equation, dou by dou u operate on that into dou z by dou u minus dou z by dou v minus dou by dou v operated on dou z by dou u minus dou z by dou v. This you can further simplify as dou square z by dou u square minus dou square z by dou u dou v minus dou square z by dou u dou v plus dou square z by dou v square. So this is dou square z by dou u square minus 2 times of dou square z by dou u dou v plus dou square z by dou v square. Got it? So this is dou square z by dou x square value. Similarly, dou square z by dou y square also you can bring exactly in the similar manner. Dou square z by dou y square is equal to dou by dou y of dou z by dou y. And this is equal to dou by dou y. And then, so dou by dou y you can replace as dou by dou u plus dou by dou v operated on dou z by dou u plus dou z by dou v. And this is equal to dou by, so dou square z by dou u square plus dou square z by dou u dou v dou square z by dou u dou v dou square z by dou y square. Now putting into the original equation, so this is equation number 2 and this is equation number 3. So this is equation number 1. So replace the equation 1 with 2 and 3. Then what we are going to get it is, that is dou square z by dou x square as dou square z by dou u square dou square z by dou u square minus 2 times of dou square z by dou u dou v plus dou square z by dou y square minus dou square z by dou u square plus dou square z by dou u dou v plus dou square z by dou y square equal to 0. Now, if you further simplify this one will cancel out, this one will cancel out, and finally, what is going to be left over is, this is the solution, dou square z by dou u dou v equal to 0. So, this is a simple equation, which is nothing but the canonical form. Got it? Understood? Any questions on this? Any questions? Last part. So which one actually you don't want? See this. This is dou square z by dou x square, you understood, right? Yeah, Samrin? Is this understood? Yes or no? Is this understood or not, Samrin? Right? So similarly, actually, if you understood this one, exactly the same procedure we followed to bring this one also. Once you got these two values, you put these two values together into this equation. That's the only thing I ever did. So once I substitute this equation, then actually the common terms actually I have cancelled it out, and finally it left with a simple equation, dou square z by dou u dou v equal to 0. That's all. Understood? Done? Noted down? Note down one more. Reduce the equation dou square z by dou x square plus 2 times of dou square z by dou x dou y. Reduce the equation dou square z by dou x square plus 2 times of dou square z by dou x dou y plus dou square z by dou y square equal to 0 to canonical form. Now actually first we write the lambda quadratic. lambda quadratic is lambda square plus 2s s lambda plus t equal to 0. So this is the lambda quadratic equation. For this one, so r value is 1, lambda square plus 2 lambda plus 1 equal to 0. Now this is lambda plus 1 whole square equal to 0. Now lambda equal to minus 1. So here actually roots are real and equal. Here actually you don't have two different variables to bring in the way we have done in the previous case of hyperbolic case. Now here if you find out this, if you notice this one, s square minus 4rt value, so s square is 2 square and then minus 4, r is 1, t is 1. So this value is 4 minus 4 equal to 0. So here s square minus 4rt equal to 0. Now this case we call as the parabolic form. So for any kind of parabolic form, you will be getting only one characteristic. That characteristic is this one. If you try to solve it, lambda equal to minus 1. So if lambda equal to minus 1, the differential equation what we can write it is dy by dx is equal to, or dy by dx plus minus 1 equal to 0. Now if you solve this equation, dy by dx, dy minus dx equal to 0. Now if you integrate these two, then y minus x equal to constant, or u can be treated as y minus x. Now what about v? Now exactly in the similar manner we did in the case of the hyperbolic equation, right? So here actually it's a parabolic case. In case of parabolic, you are going to get only one variable u. Now what about v? How we can bring the v value? Any idea? Any idea? So here actually you need to guess the v value, so that u and v are independent variables. We mean, so f of u cannot be expressed as v, or f of v cannot be expressed u. So you have to identify a v value such that is completely independent of u. So let us say, so v is equal to y plus x. Now whether it is independent of u or not, that can be proved by identifying the Jacobian value dou u by dou x, dou u by dou y, and dou u by dou v by dou x, and dou v by dou y. So this Jacobian value should not be 0. If it is 0, then it is dependent. If it is non-zero, then it is independent. If then it is independent. U and V are independent. We have to select only the independent variables. In reducing the canonical form. Now in this case, if you find out the Jacobian dou u by dou x, so dou u by dou x is minus 1, dou u by dou y is plus 1, and dou v by dou x is 1, and dou v by dou y is 1. Now this is AD minus BC, that is minus 1 minus 1. So this is minus 2, which is not equal to 0. Hence, you can select V as y plus x. Got it? Not equal to 0. Hence, V is equal to y plus x. Now once you bring this V value, then the procedure is again same. You need to repeat the procedure. Got it? Understood or not? So based on the selected value of U and V, can you bring this into the canonical format? Make it fast and give me the answer, final answer. What is the canonical form of this equation? Make it fast. Done? Anybody got the answer? Anybody got it? Okay, so I think so you can solve on your own. So I think the final answer should be dou square u by, so dou square z by dou v square equal to 0, I think. So this is the simplified form of it. Anyway, so note down one more. This is elliptical case. Note down this problem. Reduce the following equation into the canonical form. Dou square z by dou x square dou square z by dou x square plus x square into dou square z by dou y square equal to 0. So now this is the standard differential equation. Now actually here s value is 0. Now this is, so r into r plus s into 0 plus t into T format. So here actually, so this part, so S is actually 0 into dou square Z by dou X dou Y should be there ideally. So the lambda quadratic equation is lambda square plus 0 plus X square times of 1 equal to 0. This is the lambda quadratic equation. Now this is lambda square plus X square equal to 0 because S is equal to 0. And then B square minus 4AC, that is S square minus 4RT. This value, if you find it out, this value S is 0 minus 4 times of R is 1, T is X square. So this value is minus 4X square. Now X square, whatever may be the value, it is always a negative positive value. Minus of 4X square will always be a negative value. Hence, this is an elliptical form. Now if it is elliptical form, then actually, so lambda square is equal to minus X square, or lambda is equal to plus or minus Ix. Now if it is plus or minus Ix, then dy by dx plus Ix equal to 0 and dy by dx minus Ix equal to 0. Now this is dy plus Ix dx equal to 0 and dy minus Ix dx equal to 0. Now if you integrate either sides, then let us say this is y plus Ix square by 2. I call this as alpha, and y minus Ix square by 2 equal to beta. Got it? So here actually the complex roots are coming. Alpha is equal to y plus Ix square by 2, comma, beta equal to y minus Ix square by 2. So two different roots we have got for the lambda quadratic, right? So those two roots actually, if you substitute it, then this function, lambda function, is coming out to be y plus Ix square by 2, y minus Ix square by 2. Here actually the roots are complex conjugates. Then the way you need to select the uv values are, so this value you can solve for the u value and v value. Here actually this value you can call as u and this value you can call as v. Got it? Got it or not? So u is equal to y and v equal to x square by 2. Then actually when you select these values, you can identify the so Jacobian also, dou u by dou x, dou u by dou y, and dou v by dou x, and dou v by dou y also you can verify it. This value is dou u by dou x is 0 and dou u by dou y is 1, dou v by dou x is 1 x, right? Dou v by dou y equal to 0. So this is AD minus BC, 0 minus x. So this is not equal to 0. Got it? So hence actually you can take this as the independent, then you can identify in terms of u and v for the original differential equation. Got it? So then actually the procedure is similar. Again you can find out dou z by dou u is equal to dou z by dou x is equal to dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. Similarly, dou z by dou y equal to dou z by dou v, dou u into dou v by dou x, sorry, dou u by dou x plus dou y. Okay. So dou z by dou v into dou v by dou y. So this is how actually you can find out. Again, the procedure is exactly the similar manner. Got it? So you can bring into the canonical format. So after identifying all the values of S, R and T, Any questions on this? Any questions? No. So this is what is the canonical format. So in the canonical format, actually, you are bringing the complex differential equation into a solvable, easy form of differential equation. That is the only thing we are doing. Now, whatever may be the kind of differential equation we are going to get it, whether it involves variables or whether it involves only the constants, the procedure is same. So there are three different cases we have analyzed. That is the hyperbolic case, parabolic case, and elliptical case. Hyperbolic case is where the discriminant value is positive, where the roots are real and unequal. Now, in such case, you are going to anyway get two different characteristics, that is u and v. So you can express the original equation in terms of u and v. That is one case. And the second case is the roots are real and equal, which we call as the parabolic equation. In case of parabolic equation, you are going to get only one root or the only one characteristic for the lambda. So that characteristic value, you can use it. And then the other characteristic value, you have to guess it so that it is independent of the value which was already selected as u, right? So that independence, you can check it by finding out the Jacobian value, if it is equal to 0 or not. If it is 0, then you cannot take that as the one more variable. If it is non-zero, then you can take that as a variable. You can bring your own variable of your own interest, any kind of combinations with x and y. But the combination actually, that should make your work easier. And then the third case is the elliptical case, where the b square minus 4ac value is negative, that is s square minus 4rt value is negative. Then the roots are complex conjugates. In that, the real part and imaginary part you can take as the two different characteristics and then try to bring it into the canonical format. Got it? I hope no other questions are there. Got it? Okay. So with this, I would like to conclude this canonical forms. So in the next class, I am going to take up the characteristics, Cauchy's method of characteristics. Yeah. So that's all for today. Yeah. Thank you. Good night.